Let's go back and remember a little bit of algebra. Let's suppose that we have these two dots, 0, 1, and 2, 5. We can graph them on our graph paper. Each one of these marks then, each one of these lines on the grid represent a half, since we're at 2, 4, 6 here. So 0, 1 would be right there. And 2, 5 would be right there. And we could draw a line, straight line through those dots, a mostly straight line anyways, and we could find the equation of that line. In order to find the equation of a line, of course we need the slope, which is given the formula y2 minus y1 over x2 minus x1. And all we need to do here is name one of these points x1, y1, and the other one x2, y2. And then use the formula 5 minus 1 over 2 minus 0. So we'd have 4 over 2, or just 2. Which makes sense, because to get from a dot on this line to any other dot on this line, we would go up 2 to the right 1. And there's a dot on the line. 1, 3, and then up 2 to the right 1. And then to finish finding the equation of the line, we could use the linear form y equals mx plus b. Use one of these ordered pairs for x and y, and use 2 for m, and then solve for b, which we already know is going to be 1 because we have the y-intercept here, 0, 1. But just to carry this out, we could use, say, this dot, 2, 5, and we'd say 5 equals the slope 2 times 2, so x is 2 when y is 5, plus b. So 5 is 4 plus b. Subtract 4 from both sides, and b is 1. So the equation of this line is y equals 2x plus 1. And these two dots that we had from the start, 0, 1, and 2, 5, both satisfy this equation. One of the purposes of carrying out this process is to quantify the effect that changes in x have on changes in y. The slope tells us that for every 1 unit increase in x, y increases by 2 units. Now let's start again with the same two dots, 0, 1, and 2, 5. And let's plot that line again. But this time, let's treat those two dots as the first two correlation points for two variables. So if we were to draw this line through here then really what these two dots would represent would be a scatter plot. And we draw our line of best fit, the line that best fit that particular set of ordered pairs. But now let's throw a third in there, and let's say that this time that correlation gave us a value of 4 when x was 1. So that dot would actually not be on this line. And so this scatter plot then isn't really defined by this line anymore. We've added a third dot that isn't exactly collinear with the first two. Any line that we were to draw through this scatter plot then would have to take into account that this slope is going to have to change a little bit now. Some sort of a linear relationship that would model the correlation between these x and y variables. But again, it's not going to be a line that would contain all these dots. Actually then, what would happen is there would be some difference between the actual observed ordered pairs and those that would be predicted by whatever line of best fit that we might come up with.